Okay, now we are going to study with the polymerization reactions of aldehydes and ketone carbonyl compounds. Okay, so first let us start with the very first member of carbonyl compounds. Okay, polymerization of carbonyl compound is the main topic. In that first topic is first member of carbonyl compound. What is the first member of carbonyl compound? That is formaldehyde. Okay, so very bright chances of questions based on this, because it is easy to form the questions. Okay, they are very important for the entrance point of view, but direct, there is no much twist in this one. Okay, they are very easy questions. Only thing, awareness is required. Okay, so first, formaldehyde. There are different types of polymerization. Even in the polymerization of formaldehyde also, there are different types. So what are the different types? What are the condition? What are the product? We are going to study in detail. Okay. So first, aqueous solution and heated. First condition is that when aqueous solution of formaldehyde, just heated, only heating, then it polymerizes to give a crystalline solid. It gives a crystalline solid, polymerize many moles of many molecules of formaldehyde combine with each other to form a crystalline solid. That crystalline solid is called as a paraformaldehyde. So direct questions will be like this. Now, depending on this is the conditions, what conditions you are providing. You are heating, and what you are heating with the aqueous solution, and what you are obtaining, crystalline solid, and what it is called as formaldehyde. But it also depends upon the number of molecules. This is the general equation. N moles of HCHO on heating. This is aqueous solution on heating undergoes polymerization to form paraformaldehyde. Okay, to form paraformaldehyde. But this type of reaction can take place only when this N value is greater than 6. N value should be greater than 6, and this cannot take place beyond 100. This polymerization is possible only between 6 and 100. Above 6 but below 100. Even in between that also there is a condition. If it lies between 7 to 50, 7 to 50, it is going to be a linear polymer. It is going to form straight chain polymer. Okay, and if it is greater than 50, including 50, it is linear polymer. Above 50, the like 51 to 99, 59 to 51 to 99 or 100, then it is going to be cyclic polymer. Okay, so what are the condition? One more again highlighting. First, aqueous solution of formaldehyde heated. What solution? Aqueous solution of formaldehyde heated. What it will give? Crystalline solid it will give, and that crystalline solid is called as a paraformaldehyde. And this type of polymerization takes place only when number of carbons are above 6, below 100. But if it is below 50, then it is going to be a linear polymer. If it is above 50, it is going to be a cyclic polymer. I think all of you have noted this, and specifically these are the objectives, direct objectives. Okay, main I anticipating is paraformaldehyde. If nowadays integer type question, okay, so in integer type question, these questions may be based upon 6 and 100, based upon 50, based upon 50 cyclic polymer. Okay, so as per the question, you have to be prepared. Okay, first condition of formaldehyde we have studied. In the first condition, only simple heating of aqueous solution of formaldehyde. Now the condition is changed. The condition is, instead of heating, it is kept at room temperature. Now what is maintained? Room temperature only. And instead of aqueous solution, We are acidifying it in presence of concentrated sulfuric acid. Then 3 moles of formaldehyde combined together to form this one. Okay. So like their para-formaldehyde is important, and here you can see so many names. Para-formaldehyde is linear or cyclic polymer more than 6. Number of carbon atoms should be more than 6. But in meta-formaldehyde, this is nowhere related with the ortho-meta-para. Don't get confused with the benzene. Okay, they are not positions of the positions in the benzene. They are simply temperatures and conditions. If concentrated sulfuric acid is used room temperature, it is called metaformaldehyde. Aqua solution is heated, then it will be giving the paraformaldehyde. Okay, so this mechanism part and the technique, trick to remember the formula and trick to remember the mechanism that I am going to tell you. Other than the metaformaldehyde, this is also called as a trioxymethylene. So when you go through the structure, automatically will come to know. And this we have already studied in the trioxane in the cyclic ether chapter. In our lecture of cyclic ether, we have done cyclic oxane. Okay, 135 represents what? Position of the oxygen. First position, third position, and fifth position of cyclohexane occupied by oxygen. That's why it is called as a trioxane. Okay, so for easy mechanism, for easy understanding, for easy remembering, try to write HCHO like this. CH2 double bond O. Okay. Then what you will write? CH2 double bond O. Then what you will write? CH2 double bond O. Okay. So 3 moles. If you write like this, then it will be easy for you to remember, easy for you to write the product. And in this condition, what happens? Which bond will break? Simply, it will break a single bond, pi bond of the double bond. So this pi bond will shift and form as a strong sigma bond. Pi bond shift and form as a strong sigma bond. Pi bond will shift and form as a sigma bond. Okay. So then the resulting structure, I think these are all names I think everybody noted. So I am going to eliminate it. Metaformaldehyde, trioxymethylene. So what will be the product here? Then I will try to write it here itself. CH2, okay, CH2 single bond oxygen, single bond CH2, then C oxygen, okay, then it is going to be oxygen, it is going to be CH2. So it is isostructural, similar to benzene, but in the place of the CH, it is some places it is CH2, in some places it is oxygen, where it is to be CH double bond like that, but everywhere it is single bond only, and it is isostructural to benzene. Okay, so metaformaldehyde nowhere related with the structure, it is related to condition only. Meta represents presence of concentrated sulfuric acid. Trioxymethylene, CH2 is called as what? Methylene. Methylene is also there, 3, and 3 oxygens are also there. That's why it is called as a trioxymethylene. This logic also I told you, 135 trioxane, 135, 3 oxygens are there. That's why it is called as a trioxane. These are the methods to remember. So we have completed the 2 conditions of polymerization of formaldehyde. In the first condition, we are getting paraformaldehyde. Aqueous solution is heated. In the second condition, we are heating the, we are not heating, we are keeping it with the concentrated sulfuric acid. In the first condition, more than 6 carbon atoms are required. In the second condition, only 3 moles are required. Okay. Now we are into the third part. Now we are into the which part? Third part of the polymerization of formaldehyde. So if you are in touch with the chronology, okay, which pattern we are following? First, simple heating without any uh, reaction with water, aqueous solution. Second, we have used acid. Now what we are going to use with base. Okay. So that is what we are having here. When aqueous solution of formaldehyde. When aqueous solution of formaldehyde kept with the lime water. What is this? I think it is not clearly visible. It is lime water. That is base only. First, only aqueous solution. Second, concentrated sulfuric acid. Third is lime water. And first on heating, second room temperature, third dark room. And that first one immediately after some time, then it will take 5 to 6 days. And first one is paraformaldehyde, second one is metaformaldehyde, and here it is Formose. Okay, and it is a sweet solution. Simple, it is a sugar only, like, okay, sweet solution called as a Formose. So here it is an example of linear polymer. That's C6H12O6. C6H12O6 is a linear polymer example and it is called as a Formose. Okay. So all the three polymerization, I think, is it understood? Okay. Okay, whatever the formaldehyde polymerization studied, this is more important and difficult to study and memorize. That's why comparative study will help you. Okay, polymerization of formaldehyde in done in how many parts? In the three parts. What is the first part? Aqueous solution and heated. Second part, what it is? Concentrated sulfuric acid and room temperature. Third party what it is? Lime water and kept in dark for 5 to 6 days. How many days? 5 to 6 days. Okay. And n value for it. N value will be n greater than 6, but n should be what? Less than 100. And here if it is n is greater than 50, polymerization is cyclic polymerization. If n is less than 50 but above 6, then polymerization is linear polymerization. And here always cyclic polymerization with 3 molecules. Here always linear polymerization with 6 molecules. Okay. So, and the resulting product here it is paraformaldehyde, this is metaformaldehyde, this is Formose. Formose, which type of solution? It is a sweet solution. What solution? Sweet solution. Okay. This table is going to be very helpful to you. So better to take a screenshot, take a pause, or write in your notebook. Okay. Okay. Now, till now we have studied for polymerization of formaldehyde, but it is addition polymerization. Polymerization is further divided into two types: addition polymerization, condensation polymerization. What is the difference? If during the reaction, during the polymerization, no other product is formed, then it is called as a addition polymerization. If products are formed, but they are not along with them. There are certain small molecules like H2O, HCl, they are eliminated. Then it is called as a condensation polymerization. And here we are going to use two types of molecule. First example is reaction with ammonia. What is the first example? Reaction with ammonia. Aldehyde, 6 moles of formaldehyde combines with 4 moles of ammonia to form hexamethylene tetraamine. What is the name? Hexamethylene tetraamine. And it is specially called as a urotropine. Very, very important. In the previous, paraformaldehyde is important, and here urotropine is important. And structure wise, there it was difficult to form that cyclic trimerization, and here also very difficult. But let us make it very easy by explanation. Okay. So CH26N4 plus C, small molecules like water are eliminated. If such elimination is done, then it is called as a condensation. In the previous equation, now you can observe again, there is no such other product. Only one product is there. That is called as a addition polymerization. Addition polymerization, how many products? Three products. Paraformaldehyde, metaformaldehyde, and Formanose. Now, in the condensation polymerization, we are doing the polymerization of formaldehyde with 4 moles of ammonia, 6 moles of formaldehyde, 4 moles of ammonia. It gives urotropine. Okay, it's already several times it is a repeated question. It is used in urinary infection. Urinary infection. Okay, used in treatment of urinary infection. Okay, to avoid urinary infection, this used in the medicine. Okay, now main thing is how to draw the structure, why it is called hexamethylene tetramine. I think reason is understood. Now how to draw it, listen carefully. First, what you will do at the alternate places, at what places? Alternate places. Okay, try to write the structure like this: CH2, N, CH2, CH2, CH2. Alternate places CH2, alternate places it is N, CH2, 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 N, N, N. And in the center also again N. Okay, between the CH2 you write as a, sorry, between the N you write one more CH2. Okay, now CH2 can form only two bonds, so with this you can form a beautiful hexagon. Okay, and between them nitrogen can form three bonds, so their structure also over. Okay, so this is the structure of the urotropine. Okay, so because in the examination they may ask number of bridged nitrogen, number of CH2N linkages, so structure part also you should be clear. And while drawing the structure directly, if you remember, there are chances, so tricks are necessary for drawing the structure. First, what I have done, I have formed a hexagon by keeping the alternate nitrogen and CH2. Okay, and at the center also I placed a nitrogen. Between two nitrogen, everywhere I kept the CH2. So this is the structure of CH2 6 and 4. What it is called as hexamethylene. 6 CH2 are there. That's why it is called hexamethylene tetraamine. What it is called as hexamethylene tetraamine. That name is not much important, but urotropin is more important and its use is more important. So, what condensation, sorry, what polymerization it is? It is a condensation polymerization. On condensation polymerization of formaldehyde, a urotropin is formed, which also involves loss of small molecule like water. Okay. Okay, there is another condensation polymerization important. What is that? Condensation polymerization of formaldehyde with phenol. Okay, so the previous product was important in medicine, but this product is important in electrical appliances. Okay, this is called as Bakelite. What it is called as? Bakelite. Okay, Bakelite is very much useful in the switch. Okay, so here first phenol with formaldehyde, same as it is a condensation polymerization, it will involve the loss of water molecule. Loss of water molecule. Okay, so when water molecule is lost, like here H, here OH. Okay, and that will be attached here. So like this cyclic polymer, this is called as a cross-link polymer. Polymers is again you might have studied or you will study in the polymers chapter: thermosetting polymer, thermoplastic polymer. This is an example of thermosetting polymer. This is because of the cross linking, this CH to CH2. If like this and like this, then it is called as a thermoplastic and it is a linear polymer. But because of the cross linking, because of this cross linking, this cannot be remolded. This cannot be remolded. That's why they are called as a thermosetting polymer. Okay, so that example is what? Bakelite. What is the reason it cannot be remolded? Because of the cross linking, and because of the cross linking only, it is highly strong. It cannot be bent, it cannot be changed into any required form. Okay, so that is the reason behind the strength of the bakelite. Even though electrical shock is there, that can withstand, hence it is used in the manufacture of switches. Okay, so this is about the condensation polymerization. As a polymerization of formaldehyde, total broadly we have studied how many parts? Two parts. What are those? Addition polymerization, and second one is condensation polymerization. Addition polymerization is further divided into how many? Three types. Condensation polymerization we have studied into two types. Okay. Any doubt about this? Again, I will write as a short form. In short, polymerization of HCHO. Basically, how many types? Two types. First one is addition polymerization. Second one is condensation polymerization. Okay. In addition polymerization, how many types further? Three types. In addition polymerization, how many types? Three types. Okay. First one is aqua solution, comma heat. Second one is concentrated H2SO4. Third one is lime water. Okay, lime water. Understood? And what is the product here? These products are also important. Paraformaldehyde. Paraformaldehyde. Here it will be metaformaldehyde. And here it is Formanose. Okay, Formanose. And condensation polymer only two types. Okay, first one is with NH3. What is the product here? It is urotropine. Which tropine? Urotropine. And second is with phenol. Formaldehyde with phenol. What it is given? Bakelite. Okay, what it will give? Bakelite. This is the summary of the polymerization of formaldehyde. So there are many important internal points also. Just for revision in the last moment, it is better tool. Okay, so let's see in the next class about the further lectures.